Welcome to my presentation. This presentation is part of the playlist The Chain Rule. In this presentation, we will be solving problems using the chain rule. Let's look at some example problems. Let's say we have a function y is equal to minus 3, the fourth root of 2 minus 9x. We want to find the derivative of this complex function. So the way we want to solve these types of complex functions is to be able to identify the inside function and then identify the outside function. First of all, we want to note something here. Negative 3 is a constant, so we're going to keep that constant till the end of the problem, and then we're going to bring it back and then use that for the simplification process. For now, we want to identify the inside function. Let the inside function be u, and that is equal to 2 minus 9x. Let u be equal to 2 minus 9x. Therefore, outer function y we can write as fourth root of u. We can write the radical terms in terms of exponents as shown here. Fourth root of u we can express in exponential form as u to the power of 1 over 4. Now we have two different functions. U is a function of x and y is a function of u. We can differentiate u with respect to x. When we do that, du by dx we can write as d by dx of 2 minus 9x. D by dx of 2 is 0. D by dx of 9x is 9. So when we simplify it, it's going to be negative 9. So on this side, y is a function of u. Therefore, we're going to differentiate it with respect to u. dy by du is equal to d by du of u to the power of 1 over 4. We can use the power rule here. And when we use the power rule and simplify, we can write as 1 over 4 times u to the power of 1 over 4 minus 1. When we simplify it, it's going to be 1 over 4 u to the power of minus 3 over 4. 1/4 minus 1 is minus 3/4. So now we can use the chain rule. The chain rule is stating that dy by dx is equal to dy by du times du by dx. dy by du is this and du by dx is this. So when we apply the chain rule, we can write dy by du as equal to 1/4 u to the power of negative 3/4 like that times du by dx is negative 9. When we combine this, we can write it as 1/4 times negative 9 is negative 9/4 like that. U to the power of negative 3 over 4. We cannot have u as part of the answer. So therefore, wherever we see u, we're going to substitute 2 minus 9x. So therefore, now we're going to bring back that negative 3 which we had initially in our problem, that negative 3 there, and then put it in the final solution here, negative 3 times negative 9 over 4, and then instead of u we're going to write 2 minus 9x, the whole thing raised to the power of negative 3 over 4. So negative times negative is a positive. 3 times 9 is 27. In the denominator we have a 4. We are expressing this negative exponent as a positive exponent by bringing it to the denominator. 2 minus 9x to the power of 3 over 4, and that is our answer. That is where we want to, this is the way we want to solve complex problems using the chain rule. Let's look at another example. Let's say we have a function y is equal to the square root of 2t squared plus 5t plus 2. We want to identify the inside function and identify the outside function. Let u be the inside function. Therefore, let u be equal to 2t squared plus 5t plus 2. Therefore, the outside function will be square root of u. So we can express the radical term as an exponent. The reason we want to do that is to be able to use the power rule when we differentiate it. So now we have two functions, u as a function of t and y as a function of u. We can differentiate u with respect to t, and we can differentiate y with respect to u. Let's start here. Du by dt is equal to d by dt of 2t squared plus 5t plus 2. So d by dt of 2t squared, we can write that as 2 times 2 t to the power of 2 minus 1, like that, and d by dt of 5t is 5, and d by dt of 2 is 0. So now when we simplify this, it's going to be equal to 4t plus 5, and then on this side, y is a function of u, therefore we're going to differentiate it with respect to u. Dy by du is going to be equal to d by du of u to the power of half. We're going to use the power rule to simplify it, and when we simplify it, it's going to be 1 half u to the power of 1 half minus 1, and that simplifies to 1 half u to the power of minus 1 half. Now we are ready to use the chain rule. The chain rule is stating dy by dt is equal to dy by du times du by dt. Dy by du is this quantity here, and du by dt is this quantity here. So therefore, we can write it as 1 half u to the power of minus 1 half times 4t plus 1, which is that. So now we can put everything together. 4t plus 5 is in the numerator, and in the denominator we have 2. I am expressing u to the power of minus 1 half. When we bring it to the denominator, we can express it as a positive exponent, so therefore u to the power of minus 1 half will become plus u to the power of plus 1 half, like that. So now we have 4t plus 5 divided by 2 u to the power of 1 half, like that. But we cannot have u as part of the answer, so therefore we're going to substitute the value of u as equal to 2t plus 2t squared plus 5t plus 2. Okay, so when we do that, we can write it as 4t plus 5 in the numerator divided by 2 times, instead of u we're going to write this 2t squared plus 5t plus 2, the whole thing raised to the power of 1 half. We also know we can that we can express an exponential term as a radical term, as shown here. We can express it as 4t plus 5 in the numerator divided by 2 times the square root of 2t squared plus 5t plus 2. And now expressing the answer in this term, this form or this form is absolutely correct. So therefore, this is the way we want to be able to solve complex problems using the chain rule. Let's look at another example. Let's say we have an example, we have a function of this kind, y is equal to the square root of x cubed minus 2x plus 5. We want to find the derivative of this complex function. We want to be able to identify the inside function and then also identify the outside function. Let's call the inside function as u, and that then it will be equal to x cubed minus 2x plus 5, and therefore the outside function y is equal to u to the power of half. So d, we're going to differentiate, u is a function of x and y is a function of u. Here u we're going to differentiate it with respect to x, and then here y we're going to differentiate it with respect to u. Let's start here. Du by dx is equal to d by dx of x cubed minus 2x plus 5. So d by dx of x cubed, we're going to use the power rule. When we use the power rule, it simplifies to 3x to the power of 3 minus 1. And then d by dx of 2x is 2. D by dx of 5 is 0 because 5 is a constant. When we simplify it, it's going to be 3x squared minus 2 on this side. And on this side, y is a function of u. We're going to differentiate it with respect to u. Dy by du is equal to d by du of u to the power of half. So dy by du is equal to 1 half u to the power of 1 half minus 1. When we simplify it some more, we can write it as 1 half u to the power of minus 1 half. So now we have the value of dy by du. We have the value of du by dx. So therefore, we are now ready to use the chain rule and then arrive at the solution. So dy by du is 1 half u to the power of minus 1 half. That's what we have here. The value of du by dx is 3x squared minus 2, which we have here. Now when we put it together, 3x squared minus 2 is in the numerator, and then 2 is in the denominator. U to the power of minus 1 half, when I express it as a positive exponent, I can bring it to the denominator and write it as a positive exponent as shown there. Now we cannot have u as part of the solution. So therefore, wherever we see u, we're going to substitute u cubed minus 2x plus 5 like that. Therefore, when we do that, 3x squared minus 2 will still be in the numerator, and in the denominator we have a 2, and then instead of u we're going to write this part, x cubed minus 2x plus 5, the whole thing raised to the power of half like that. And we can express this whole quantity, um, this exponential quantity, as a radical term as shown here. 3x squared minus 2 is in the numerator, divided by 2, the square root of x cubed minus 2x plus 5. This is our solution. We can express our solution this way or this way. Both ways of expressing the solution is absolutely correct. This is the way we want to solve, this is the way we're going to solve complex problems using the chain rule. In my next video presentation, we will be solving more problems using the chain rule.